Check yourself before you take an assessment that might affect your grade. And in this edition, we're going to be talking about position time graphs, things we should be able to understand from a position time graph, and how they will affect our lives. Very emotional stuff. Now, you're going to answer these 3 questions for me. You can obviously talk about some more things, but this is the focus of this today's objective. There we go. That's English. Is 1, based on the position time graph you see over here. That's right. We have 2 objects, red versus blue. Great Halo joke thing. It's hysterical. By the way, the correct answer is always red. I mean, unless it's wrong, but I'm always red when I play board games, so that's why I do red. Side note's done. So create a velocity time graph based on this position time graph. Determine who traveled the greatest distance. Is it red versus blue? I don't know. You'll find out. Determine who had the greatest displacement. Was it red? Was it blue? I don't know. You'll look into that. All right. So let's dig deeper into this. So I'm going to present the answer, okay? So I want you right now to pause your video, and you're going to hack away at these, and I'm going to then reveal the answer. And here's the answer in 3, 2, 1. Ta-da! So this is the velocity time graph you should have created. I color-coded it red, red. Blue, blue. And then greatest distance, well, I told you it was red. I don't know why you didn't believe me, but it's red, 15. And the greatest displacement is also red at 15. Oh, poor blue. You were so close. Oh, well. Because like I said, I'm always red when I'm gaming. So there's your answer. Now, if that didn't make total sense to you, you didn't get the exact same answers, then hold on and wait, and I'm going to kind of walk you through this, or maybe give you some hints, see how that goes for you, and see where that takes you. So wait around if you need some extra help. And here we go. Helping in 3, 2. Wait, am I helping? No, I should be more helpful. Okay, I'll be helpful now. I swear. Time graph. You have to understand the meaning of everything about position time graph. So the first thing you have to understand when you create the velocity time graph is that slope on a xt graph is the velocity. All right, you don't actually care where the line is. You don't care how high it is, how low it is. It's totally irrelevant. All you ask is, hey, you. Yeah, you. I'm talking to you. Like you, blue. This line, this first line segment. So first of all, we have 2 separate slopes, so therefore we're going to have 2 separate velocities. I just asked myself, are you positive, are you negative, or are you 0? That's all I asked myself. And then based on those answers, that's what I'm going to draw over here. Am I going to draw a positive line? Am I going to draw a negative line? Or am I going to draw a 0 line? And then, hey, oh, look, you changed. Ask yourself the same set of questions. Okay? So see if that helps get back to, how to figure out what that is. So there's your first hint. All right? So I'd say pause it, see if you can then go back and solve it now. All right, second hint. All right, so hopefully that helped with the velocity time graph, because that's really the crux of everything. When you're trying to determine the travel the greatest distance, remember that distance, I can't spell distance. Distance is your change in position, but it's never negative. All right, so it's your change in position, it's never negative. So really you just had to ask yourself, okay, how far did you go? So for red, I said, well, I started at -5 and I ended up at 10. So I went a grand total of 15. And then here, I did nothing. I didn't go anywhere. So my total distance is just 15. All right, now this one's got some negatives and some positives. But remember, the negatives and positives don't matter because everything's positive in distance. All right, so that's your hint for distance. I should talk about displacement too, shouldn't I? Okay, I'll talk about displacement in a second. Okay, I'm thinking about it. All right, hint for displacement. All right, hint for displacement. Remember, the key things about displacement. There's an L in there. No, it's over there. There we go. Yay! Sure. Displacement, spelled horribly wrong, is actual just change in position. So this one doesn't care. It's your final minus your initial, and it can be positives, it can be negatives. Now we have 2 separate things here, but it doesn't care. That's why displacement's awesome. I don't have to break it into segments. So displacement just says, oh, okay, I started at 10 and I ended at 0. 10 minus 0 is 10. But this guy over here is like, I started at -5, I ended at 10. 10 minus negative 5. You do the math. All right, so displacement's a lot clearer because I don't have to break up into steps. Distance, I got to break up into all the individual steps because there can never be a negative. All right, so I got to take them piece by piece. So there's your hints on solving these types of graphs with these types of questions. May the net force be with you.